2018 Leaving Cert Higher Level Paper 1 question 7 was a functions question with graphing involved and some calculus. We're told in this question that the time in days of practice it takes Jack to learn to type X words per minute, WPM, can be modelled by the function t of x is equal to k by the natural log of 1 minus x over 80, where x is between 0 and 70. It's a real number and k is a constant. Part 1, you're asked, based on the function t of x, Jack can learn to type 35 words per minute in 35.96 days. Write the function above in terms of k and hence show k is equal to minus 62.5, correct to one decimal place. So t of 35 is equal to 35.96. So k by the natural log of 1 minus 35 over 80 is equal to 35.96. K times the natural log of 80 over 80 minus 35 over 80, 45 over 80, is equal to 35.96. So k, if we divide across by the natural log of 45 over 80, k is equal to 35.96 divided by the natural log of 45 over 80. So type this into your calculator. It gives minus 62.499. Correct one decimal place, minus 62.5. Part B of this question, we're asked to find the number of words per minute Jack can learn to type with 100 days of practice, correct to the nearest whole number. So we have our function, minus 62.5, which we got for k, by the natural log of 1 minus x over 80 is equal to 100. So the first thing I need to do is divide by 62.5, or minus 62.5. Now, how do we get rid of this natural log? If we think about it in simpler terms, we have the natural log of 20.085 equals 3. How do we get rid of the natural log? Well, what we do is we raise the right hand side. That's the power that we will use to raise e to this power. So e to the power of 3 is equal to 20.085. So similarly here, e to the power of this number is equal to the left hand side without the natural log, 1 minus x over 80. So simplifying this, we have a minus x over 80, so we bring the x over 80 to the right and the e to the power of 100 over minus 62.5 to the left. We can simplify just down then in terms of x. 80 times the left will be equal to x. So we have 100 over minus 62.5. So typing this into your calculator gives 63.84, and we were asked to the nearest whole number, so 64 words per minute. For part C of this question, you were given this table and asked to complete it. So straightforward enough, set your calculator up with minus 62.5 by the natural log of 1 minus, and start with 0 over 80, and then just go back and change it to 10, 20, 30, 40 and so on, and you should get the following solutions. So the answers you should get are 0, 8, 18, 29, 43, 61, 87, and a big jump to 130. So this looks like pretty much an exponential growth curve. So let's graph it. So it looks something like this. Exponential growth. So the lesson here is the more you practice, or the longer you spend practicing, the better you get. And the same is true for higher level maths. So a simpler function that could also be used to model the number of days needed to attain x word per minute is p of x is 1.5x. So draw this on the graph. So we just need the endpoints. P of 0 is equal to 0. So it starts at 0, 0. And P of 70 is 1.5 by 70. So 70 and 35, 105. So 70, 105 is my second point. So let's go and graph these. And just check what 70 was in the previous one. It was 130, so it's going to be below it. 70, 105. Looks like it's approximately here. And 0, 0 here. So we'll try and draw a straight line between those 2 points. That's label it as well. P of x. The other one is T of x. Part E asks us to use the graphs above to estimate the solution to h of x is equal to 0 for x greater than 0, where h of x is equal to p of x minus t of x. Well, that's just a fancy way of looking for the point of intersection between the graphs, and they're not looking for the point at 0, 0. So this point here. So we drop our line down. We get to approximately, on my graph it looks like 61. The exact answer they're looking for is 62. The margin of error here is plus or minus 2. So we get 61. The margin of error is plus or minus 2. So anywhere between 60 and 64 will get full marks here. Now we're asked to use calculus to find the maximum value for h of x to the nearest whole number. So h of x is p of x minus t of x. So here these two are here. So we know we got to differentiate, let it equal 0, solve for x, and then put x back into our original equation, which is this one, to find the max value. So we differentiate this. H prime x is going to be 1.5. Now the minus is here and here, so this is going to give me a plus, these two. So we're going to get plus 62.5. We know that ln x, when we differentiate it, goes to 1 over x. So in this case, it's going to go to 1 over, oh, I've written this out wrong. I left out the 1, just put it in there now. So it's the natural log of 1 minus x over 80, so 62.5 times 1 over this guy in here. So the 1 over x part, which is 1 minus x over 80. And then we have to multiply by the differentiated bracket. So if we differentiate this, we're just going to get minus 1 over 80. So multiply by minus 1 over 80. And we would have to let this equal 0. So we're going to get on top, we're going to get 1.5. On the top, we have a 62.5, a 1, and a minus 1. So on top, we're going to have minus 62.5. On the bottom, we're going to have this 80 by this 1, which is 80, and this 80 by x over 80, which is just kind of cancel the 80s, so minus x equals 0. So if I bring the negative across, I get 1.5 is equal to 62.5 over x 80 minus x. Cross multiplying, I'm going to get 1.5 by 80, which is 120. Minus 1.5x is equal to 62.5. I'm bringing both over. We're going to get 62.5, 120 minus that. It's going to be 57.5 equals 1.5x. So x is going to be 57.5 divided by 1.5, which if we type into a calculator, it's going to give me 38.333. And if we put this back into our original equation, h of 38.33 is going to give me 1.5 by 38.33 plus 62.5 by the natural log of 1 minus 38.33 over 80. That's going to gives me 16.7. We were asked the nearest whole number, aren't we? Nearest whole number. So that's going to give me 17. And that is in time. So that's 17 days.